All right, so 3.1 is exponential functions and their graphs. So we're going to start with exponential functions and graphs of those, like something to the power of x, right? And then we get into logs. So that's what this chapter is really, exponential functions, logs. We get into like E and ln and solving all those different kinds of questions. So I'm still trying to tweak what I think will happen in this chapter, but I'm thinking I will do a quiz without a calculator, which is like graphing and simplifying logs. And then when you get your test, you'll have a calculator because there's things you can't do without it. Okay, so instead of splitting it up, I don't think I'm going to be able to split it in 2 days the next round. We just lose too many instruction days between now and the end of the quarter, and they haven't told us if we're doing midterms or not. So right now we're planning on timing, assuming that there's midterms, and then should there not be midterms, we'll have a little bit more time at the end to kind of play around, make sure we can get 3 tests and 3 quizzes. But for now, my goal is 3 tests and 2 quizzes again like we did this time. And probably not 2 days test like we did. Like I'll just have to figure it out. It's like a week, day by day around. All right, so the definition of an exponential function is a function with a base raised to an exponent. So the exponent is your variable here. So you'll see something like f of x equals 3 to the x, or f of x equals 2 to the x. Okay, the base has to be greater than 0, and it can't be 1. If it's 1, it's constant. It never changes. So it would be bigger than. That's not to say it can't be a fraction. Okay, it's not to say that we can't do a negative after to flip it upside down. But the base itself we treat without the negative. So first example, and these are the ones that require a calculator. So that's what I was saying. Some things are going to require it, and some things are not. Most likely this would not be on a quiz, okay? But it would be test-wise, is sort of what I'm thinking. But of course, as soon as I know, I'll let you know, okay? So it says to evaluate the function at the indicated value of x and then round your answer to 3 decimal places. So this is really the same thing as saying 1/2 to the x, okay? You could treat it either way. But because my exponent is not a whole number, okay, or even if it was like a positive or negative, that's not a whole number. I don't expect you to do that without a calculator. So you're just going to do 0.5 to the 1.2. And then you're going to round your answer to 3 decimal places. So 0.5, 1.2, and I get 0.43527, and so on and so forth. 3 decimal places, 435. Part B says 150 times 2 to the x, and x is negative 2.5. So I do 150, 2 to the negative 2.5, which means I'm going to raise 2 to the negative 2.5 first. I get 0.176 and so on and so forth, and multiply that times 150 without rounding it first. So you want to keep it exact in your calculator. And then multiply it times 150, and you get 26.5165, or 26.517. So simple plugging in at this point. Plugging in and letting the calculator do the work. Easy stuff. Yes? Good so far? Yeah, okay. All right, now we're going to graph. So there's a lot of, again, it's a lot of words on these slides when your book does this. I'm going to try to simplify it for you. This is characteristics of an exponential function in the form of f of x equals b to the x. So something raised to a power that has an exponent in it. The domain consists of all real numbers. So think domain goes left to right. This graph here is what we're talking about here. Okay. If my base is a whole number, okay, meaning it's going to be 2, 3, 4, all the way. If the base is a fraction, then it actually decreases as we move from left to right. But notice that the arrows are still pointing left to right. So domain is always negative infinity to positive infinity because you can plug anything into there. Now the range, there's a horizontal asymptote here. And this is not because of a rational expression. It's because when I raise something to an exponent, I can never get it to be less than 0 if it didn't start that way to begin with. So that is the horizontal asymptote would be at y equals 0, which means my range is going to be 0 to positive infinity. Now if there's a vertical shift on this, obviously it's going to move that. This is just on the parent function. It says the graphs of all exponential functions pass through 0, 1, because when you raise anything to the 0 power, it's 1. So again, this is just on my parent function. If I added something in my exponent, it's not going to be this way. But my parent function is going to be a y-intercept at 0, 1. Because if I put 0 in the exponent, my base is going to result in a 1. 3 says if b is greater than 1, then it has a graph that's increasing as it moves to the right. So if my base is a whole number bigger than 1, then it's increasing as I move from left to right. That's that green one. That's what this is. Okay? If my base is in between 0 and 1, meaning it's a fraction, not improper, then it is decreasing as it moves from left to right, and that's the teal one on my graph. So this is the green, and that's the teal. 5 says it is 1 to 1 and it has an inverse. Think about, remember your 1 to 1, right? Your horizontal line test, these are always going to pass it. So it's always 1 to 1, and if it asks you for an inverse, you could find it by switching the x and the y, which is actually how we'll graph logs. And then, so it's 1 to 1. And then 6 says the graph approaches but does not touch the x-axis, and it has a horizontal asymptote there, which is what we already talked about. Again, that's on the parent function. Now, if there's a vertical shift, it's going to shift my horizontal asymptote and change that. All right, so this just says graph the exponential function. So we literally do a t-chart here, okay? So this is what I don't want you to get comfortable using a calculator, because on the quiz or test, if I give you something like this, you wouldn't have that. So I always start, I could do -1, 0, and 1, the normal values, and I could plug it in. 3 to the -1, 3 to the 0, and 3 to the first. So what happens when I raise a base to a negative exponent?
Decimal.
Good. So if it was, because I don't have my calculator, I'm going to keep this exact. It means that this gets pushed to the bottom. 1 over 3 to the first, which would be 1/3. Anything raised to the 0 power is what?
Is it 1?
It's 1. So that's the next one. And 3 to the first would be?
3.
Good. So now I've got those points, -1 and 1/3, 0 and 1, 1 and 3. So this, I have to know, gets close to, without touching, my x-axis, or my y = 0 line, because there's a horizontal asymptote there. And it's exponential, which means once I get past that 0, 1, it grows faster. This time it grows 3 times faster than normal. If you wanted more points, you could do more points. If I plugged in 2, I'd get 9, okay? We need at least those 3 points. Domain, again, would be -infinity to +infinity. My arrows point left and right. There's no restriction on my x. My range is going to start at 0 but not include it, because there's an asymptote there. Go to +infinity. There's no x-intercept because it never crosses the x-axis. The y-intercept would be at 0, 1, okay? So think about all those things, all the overlaps of what we already know. Questions on that one?
I know the range starts at 0.
Because there's a horizontal asymptote here, so unless there's a vertical shift, which means you're going to add or subtract something after the number, my horizontal asymptote will always be at 0. So we'll talk about like what happens with the vertical shift a little bit. We'll probably get to that more tomorrow. Okay, then B says 3 to the -x. So I'm still going to plug in the same coordinate points, 0, 1, -1. This time I get 3 to the -1. The opposite of -1 becomes +1, and this is just 3. Plug in 0, 3 to the -0. -0 is the same thing as just 0, so that's 1. And then 3 to the -1 would be 1/3. So these points are reversed from what my other one was. So -1, 3, 0, 1, 1, and 1/3. Now my asymptote is still at 0, but it's decreasing. The left side is up, the right side is flattening out. So now again, domain -infinity to +infinity, range 0 to +infinity. Still no vertical shift. Questions on that? Okay.